Now we're going to look at the effect of compressor inlet superheat and condenser exit subcooling. So first of all, compressor inlet superheat by default is set at 0, so the inlet of the compressor is right here on the saturated vapor line. You can see that both in the pH diagram and over here on the TS diagram. So again, we'll take a little screenshot of our state points and operating conditions just so we can see the effect of the changes we're making. First change we'll make is the compressor inlet superheat. We'll put 10 degrees of superheat there. So the first thing we see is that point 1 is moved off the saturated vapor line out into the superheated region. See that on the pH diagram by a shift to the right, still at the same pressure, so it shifts directly to the right. On the TS diagram, point 1 is now higher than the old point 1, so it's moved into the superheated region. It's moving along a line of constant pressure at the evaporator pressure, so that is now up at a higher temperature. So that point is 10 degrees higher than it used to be down here on the saturated vapor line. Take a look at the change in operating conditions. We see that the coefficient of performance used to be 3.6. It's now increased a little bit to 3.63, so a very small increase in the coefficient of performance. The reason the coefficient of performance has gone up is notice that the refrigeration effect, the amount of energy that we're adding by heat transfer into the evaporator, has increased. So the change in enthalpy here has this extra amount, so it's larger. So if we look at the heat added in the evaporator, it's now 153, and it used to be 145. So an increased refrigeration effect. Now at the same time, the compressor work actually also goes up a little bit. Look at the compressor work. It is now 42.06, used to be 40.31. So both the compressor work and the refrigeration effect have increased, but the net effect of those two is actually a small increase in the coefficient of performance. Now we'll reset those conditions, and now we'll look at the effect of condenser exit subcooling. So that's now over at this point, and notice the default is 0, so this point is right on the saturated liquid line in the pH diagram and also on the TS diagram. So we'll put 10 degrees of condenser exit subcooling, and we see now that point is shifted over to the left into the subcooled liquid region, still at the same pressure, so it's a straight horizontal shift to the left because this axis is pressure on a pH diagram. But if we look on a TS diagram, it is shifted from that point, the saturated liquid condition, and it's moving still along the line of constant pressure, but in the liquid region, lines of constant pressure lie very, very close to the saturated liquid line. So the new point 3 is down here, and that's 10 degrees cooler than it used to be when it was up here. So we see that as a downward shift, apparently along the saturated liquid line in the TS diagram. Now the effect on operating conditions, we'll see again we've gone from a coefficient of performance of 3.6 when we had no subcooling at the exit of the condenser, and we've increased that up to 3.95. Notice the compressor work used to be 40.13 is still 40.13 because this change over here on the left side of the diagram isn't affecting the compressor work. We're back to our default compressor work. But this point has shifted over to the left. Therefore, because 3 to 4 is a constant enthalpy process, 4 has also shifted over to the left, and that's increased the refrigeration effect. So it used to be 144.57, now it's up to 158.65. So our coefficient of performance has increased because we're adding more heat into the evaporator, still the same amount of work going in the compressor.